guys, welcome to Science Lesson 6.2. So you will be reading and studying Lesson 6.2. So here are some notes for you guys. I'm just going to talk through a couple things. First of all, 6.2 is about atoms. Atoms are the building blocks of matter. So let's talk about the definition of an atom. An atom is the tiniest particle of matter. In your book, it gives the example of a penny. If you were to divide a penny into a million pieces, and then you took that piece, one of those pieces, and you cut it into a million pieces, and then you took one of those pieces and cut it into a million pieces, and so on and so on and so on, until eventually you would get to a point where the particles would not be able to be made any smaller and still be that copper penny. So the smallest possible particle of copper, that would be the copper atom. So it's the tiniest particle of matter. We call these tiny particles elements, and we'll talk about that more in our next lesson. But think about it. How many atoms of copper would a solid copper penny need to be a copper penny? You might not be expecting this answer. 30 billion trillion atoms. Not 30 billion, billion trillion. So your book shows you that number. It's 3 followed by 22 zeros. That's a ton of atoms because atoms are super, super tiny. Very, very tiny. In fact, it would take you, if you were to count up how many atoms and you were able to count a billion atoms per second, it would still take you 950,642 years to count all of those atoms. That's a lot, right? That's very, very tiny. Atoms are extremely tiny. You can't see them with a magnifying glass. You can't see them with a microscope. You need a special type of microscope, and we'll talk about that in a little bit. So let's first talk about the anatomy of an atom. Anatomy talks about the parts of something, the building blocks of something, what it's made up of. So here is an example of a model of an atom. An atom doesn't look exactly like this, but this is kind of a working model to give you an idea of what it looks like. So let's talk about the parts. The nucleus is the tiny, extremely dense core of the atom. Core means the center parts. Now the nucleus is made up of two different types of particles. First, we have the protons. Those are positively charged particles. We'll talk about what I mean by positively charged in a minute. Then we have neutrons. These are particles with no charge. So that's why you see one particle with one color and one particle with another color, because one color represents the neutrons, the other color the protons. And for most atoms, they either have the same number of protons and neutrons, or they have more neutrons than protons. Electrons, those are the little ones, the little blue ones that are going around. So the lines represent the path of the electron, because electrons are tiny, teeny tiny, negatively charged particles that dart around the nucleus. They don't necessarily go in the same orbit. It's more like your book compares it to the flight of a bee. It just kind of zip, 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 zips around the nucleus, but it's attracted to the nucleus, so it doesn't fly away. It stays around the nucleus of the atom. And so that's why you see everything kind of going around there. The electron cloud is what we call the fast-moving group of electrons surrounding the nucleus. So you see all those blue things, that's the electron cloud. Electrons orbiting at roughly the same distance around the nucleus are said to be in the same shell. And we'll talk about shells again a little bit more, but if they're all kind of the same distance, it's in the same shell. If one electron goes around at a higher level than another, it's not in the same shell as the one before. An atomic force microscope is an instrument powerful enough to examine the texture of a surface so closely that it can detect the tiny bumps of each atom. So this type of microscope is really the only type of microscope that can actually see an atom. So it's able to zoom in so far that you can see the tiny bumps of the atom. But even then, you can't see every part of the atom. You can't see the electrons zipping around or anything like that. If you were to magnify an atom so that it was the size of a person, then it would still be super, super tiny because most of it is empty space. The nucleus is a very dense, very heavy center, but most of it is empty space with the electrons zipping around it. In fact, the electrons would be the nucleus. I'm sorry, not the electrons. The nucleus would be even smaller than the dot on an I, and the electrons would be even smaller than that, even if you were to expand the atom so it was the size of a person. So that's really, really small. If you were to expand it the size of a person, the nucleus would be smaller than the dot on an I, in like the I in your book, that kind of I, the I on the computer screen, and the electrons smaller than that. Really, really tiny, right? But also really, really dense. So read your book to find out how dense they are. All right, let's talk about the charges in an atom. This is very important for you to know. Both protons and electrons have an electric charge. An electric charge is an electric force that exists between any proton and any electron, or between any two electrons, or between any two protons. So they have an electric force. An electric charge may be positive or negative. You don't have to worry what that means right now. Just know that it can be positive or it can be a negative charge. So we have a basic rule that opposite charges attract and like charges repel. So that means charges that are different will attract each other. Charges that are the same will repel each other. They'll push each other away. A normal atom has an equal number of electrons and protons, meaning that the positive and negative charges are equal. Because they're equal, that means it has no charge. It cancels each other out. Just like positive and negative numbers, if you add the same positive number to the same negative number, for example, -2 plus +2, the positive and negative cancels each other out and you're at 0. So that's what it means. Anything with no electrical charge at all is neutral. So a normal atom is neutral because the positive and negatives cancel each other out. All right, now I'm skipping over a section in the video lesson because it's a section that you can just read very, very simply. It just talks about the structure of common atoms. So what some common atoms are made up of. But atomic numbers, this is very, very important. Atoms of different elements contain different numbers of protons. So different atoms, they contain that different number of protons. But each element, each type of atom is very, very specific with the type of proton that it has, or the number of protons. The atomic number is the number of protons in an atom. Okay, it's very important, the number of protons in an atom. If you change the number of protons, you change the type of atom. So that's why we give the number of protons this specific name. It's the atomic number. So the atomic number of an element is the number of protons in an atom of that element. Because every element is composed of a unique type of atom, every element has its own atomic number, which you can find on the periodic table of elements, which is something that we'll go over more in depth later. Okay, so that's all we're going to talk about. You need to read your book for more information, so read pages 284 through 288. Complete Comprehension Check 6.2 on page 288. Complete Science Worksheet 19. And that's it. Have a great day, guys. Bye.